Hi guys, welcome to another episode of MrLopezClasses.com. We are going to continue in our book of corrosion, and in this episode, this is the episode number 2 of the chapter 2. In this episode, we are going to analyze the steels, the ferrous alloys, the stainless steels, and how you extract the metals. Different metal like aluminum, iron, gold, and we are going to analyze why those metals are good in some marine environments and why some of those alloys are not good in some marine environments. This is an special episode because in this episode we are going to try to understand why the steel, the regular steel, the plain steel is it's not good in marine environments. It's not good in the fabrication of brackets for motor mounts, for air conditioning equipment. You need fabricate those brackets, those frames in aluminum alloys, in stainless steel, pure stainless steel, good stainless steel, marine grade steel. Okay, we are going to start the analysis with the extraction of metals. And what is the meaning of that? The extracting metals and the different process for extracting metals. And we are going to start with gold. Gold is basically one of the pure metals that you found it in the environment in pure state. Only gold, only copper and platinum, they are founded in natural state. They are founded pure. However, you found that gold pure in some rivers. There are a lot of people extracting gold in some rivers like this, but also you found that gold in ore, and it's necessary to separate carbon deposits and other contaminants and separate the pure gold. And right now we are going to analyze how is that process. It's not complicated, it's simple. Gold is a special metal. Gold have another important consideration. Gold is unreactive. You cannot combine gold with any other metal. It's not possible to create alloys of gold. Gold is pure. For that reason, gold is considered the king of the metals. It's non-corrosive, is malleable, is shiny all the time. Is not possible to combine gold with other metals. Is pure and is alone, is the king. Gold is the king, is excellent, is the best conductor of electricity, and is the best thermal conductor. Is an excellent conductor. For that reason is considered the king of the metals, and for that reason is the most expensive metal. Right? It's not possible to combine gold with any other metal. If you try to combine, gold is separated. Gold float in the moment that you melt those elements to prepare the alloy. Gold float. It's not possible. It's not possible to alloy gold. Okay, my friend, how you extract the gold? To extract gold from its ore, huge grinded ores are in fine powder. Yeah, the idea is convert those blocks in powder. And after that, when you have the powder, and after that, you mix it with a special solution. With that solution, the gold is separated and the gold float. With that solution and a powder of zinc, the gold is in the bottom, and the other contaminants float on top, and it's easy to separate the contaminants, and you pour the gold in ingots. It's a regular process. Yes, the powder of zinc is added to bring the gold out. And after that, the gold is melted down and poured in molds or ingots. It's not complicated because the melting point of gold is too low. That's the melting point of gold. Is too low. And this is only to to show the procedure to keep gold. You found that gold natural or gold in ore, and this is the procedure to separate the gold. But it's simple because the melting point of gold is low. For that reason, with a little torch and basically hand tools, you can do that separation. It's not complicated. A lot of people do that process. No industrial procedures, in home procedures is too simple. Okay, we are going to continue with the aluminum and how is the procedure to the extraction of aluminum. Aluminum is critical in our industry, in the marine industry, because aluminum is the material that changed the naval industry, the marine industry, in two. I think that the naval industry and the aviation industry is before and after the discovery of the aluminum alloys. Both of them, both industries, changed dramatically with the aluminum. In the marine industry, before of the aluminum, everything was in wood. The structures, the hulls, everything was in wood. Today, wood is used in the marine industry, but less in comparison with some years ago, 50 years ago. Wood was more useful in the marine industry. Today is aluminum and different aluminum alloys, and right now we are going to analyze which type of alloys are the best type of alloys used in the marine industry. I explained in previous episodes that the majority of the metals, except those three pure metals, the majority of the metals are in natural state combined with other elements, with carbon, with sulfur, with phosphorus, with the silica, and this is the ore, and it's necessary prepare a process in order to separate those impurities in order to get the pure metal. It's exactly the same with copper, exactly the same with aluminum, exactly the same with iron. Those elements in natural state, they are combined with the other elements, with other ingredients in the alloy. In this particular case, aluminum originally is the ore is bauxite. Bauxite is a combination of carbon, hydrogen, silica, sulfur, other ingredients, and the process of separation is a special process with a special name, the Bayer process, because this is the name of the manufacturer of the equipment for that process. This is the most common process. Right now I am going to explain. The bauxite is essentially an impure aluminum oxide. The aluminum is too high in the electromechanical series. You remember the electronegativity is high electronegativity. And for that reason, the process used is the carbon reduction. And right now I am going to explain what is the meaning of that. Let me explain something about this. Because the majority of the metals in natural state, they are combined with other elements. They are basically oxides combined with other ingredients. For that reason, when you have the metals in pure state, aluminum, copper, iron, those metals try to return to the original state. What is the meaning of that? Those metals try to be oxides, because in natural form they are oxide plus other ingredients. Yeah, if you let a piece of aluminum outside, exposed to the environment, the sun, the rain, that piece of metal try to return to the original situation, oxide. In a couple of days, you see the piece of metal completely covered with a powder, different color of powder depending of the metal. Yeah, all the metals not the pure metal, the regular metals, they try to return to the original state as soon as they are exposed to the environment. For that reason, those metals are easily oxides. The oxygen attack those metals easily, right? Because those metals try to return to the original position. Remember that when the oxygen attacks those metals, produce the powder. That powder, that oxide of that metal, is a perfect isolator. However, the metal by itself is a perfect conductor. Big difference, no? When the oxygen attack produces the powder, and that powder is a perfect isolator. That powder of different metals is used with the glue to produce ceramics. Okay, ceramics are basic oxides of metals. Yes, this is the case of aluminum, and right now we are going to check what is the procedure. The ore is first converted in pure aluminum oxide. Yeah, the first step is convert the ore with a lot of ingredients in aluminum oxide. This is with a process. The name of that process is the Bayer process. Bayer process. And this is basically for electrolysis. And that solution is malted in a separated cryolite, and we separate the aluminum. This is the process. It's not complicated. Basically, yes, the crushed bauxite is treated with a moderate concentration of sodium hydroxide. This is sodium hydroxide. Yeah. Okay, the impurities in the bauxite remain as solids. All the solids are separated. The solid goes up, and the liquid, the aluminum, goes in the bottom. And you have pure aluminum goes down here, pure aluminum. And on top, you have impurities. You have sodium, you have carbon, because the electrode is graphite, is carbon. And the electrode is eroded because it's a sacrificial anode to produce the electrolysis and separate the aluminum from the sodium, from the carbon, from the sulfur. Those impurities float like solids on top, and in the bottom the aluminum is pure. And the aluminum is drained and malted in ingots, malted in shells to fabricate cast aluminum, different pieces of cast aluminum. Yeah, it's not complicated. This is a technique used for hundreds of years, and is used today. I am going to explain later in the last chapter of this book the different metallurgical procedures. In those procedures, I am going to explain the cast aluminum, cast iron, cast copper, and how is the procedure to mold it, those pieces with sand. Okay, my friend. This is the process. It's too simple. It's basically an electrolysis with a graphite of carbon, and the current, high current, normally is AC current, is introduced to the electrode, and the electrolysis is produced. The solid goes up, and the liquid goes in the bottom, and the liquid is drained. That procedure is possible because you added to the powder, the oxide of aluminum, you added hydroxide of sodium. And the hydroxide of sodium is like the catalyst that accelerates the process of separation. The aluminum goes down and the solid goes up. Yes, the hydroxide of sodium is the catalyst that helps in that separation process. Yes, it's very common, and after that the aluminum is malted in different ingots and separated. The industry of aluminum is in my opinion, the biggest industry in terms of metal. The iron and the aluminum, those are those industries that are moving all the time, because everything is fabricated today in aluminum alloys and iron alloys, especially steels. For that reason, the extraction of aluminum and iron is, in my opinion, the most important of this industry, in the metallurgical industry. Let me check in terms of, let me show to you something. In order to produce 1 ton of aluminum, is necessary in between 4 and 6 tons of bauxite. It's a lot, no? 5 tons of bauxite per each ton of aluminum. Yeah, the rest is scrap, and only 1 ton is pure aluminum. Okay, but the bauxite is abundant. There are countries with a lot of bauxite on the surface of the earth. Like now, then I am going to explain. Those are the countries: Japan, Kazakhstan, and China. Those countries produce 90% of the aluminum of the world. 90%. They have a lot of bauxite on the surface, and they produce a lot of aluminum, pure aluminum, and they export aluminum for the rest of the countries. And there are other countries dedicated to the consumption of aluminum, because they fabricate a lot of equipment, the automotive industry, the aviation industry, the marine industry, the construction, buildings, homes. They use a lot of aluminum. Those are the countries with the higher consumption of aluminum. And of course, the number 1 is Asia. Number 2 is Europe with 20%, and America 16%. Yeah, in between those three groups, it's basically 95% of the total. It's a lot, no? Asia is 55%. The consumption of aluminum is 55% in Asia, 20% in Europe, and the rest in America and Africa. Okay, this is a great picture about the consumption of aluminum in different countries, and those are the industries that have the majority of the consumption of aluminum. But the number 1 is transportation, 25%, 25% in construction, 17% in package, in electrical 12%, in machinery 10%, in consumables 6%. But yes, in transportation and construction we have 50% in both of them, in transportation and construction. Yeah, majority of the construction today, they are based not in ferrous alloys, it's aluminum alloys. Aluminum alloys are superior in durability, is less corrosive, is malleable, is luxury, is shiny in comparison with the steel alloys. Okay, but the aluminum is abundant, and the aluminum is you can collect aluminum, scrap of aluminum, and you can melt that aluminum again, and you continue the cycle. There are a lot of scrap companies dedicated to collect aluminum, and after that they process in ingots, and the industry continue and continue and continue. The price of the aluminum is not too expensive. You remember that picture? Yes. Remember that the cheapest metal is iron, and there are other metals expensive: beryllium, gold, silver are expensive. But aluminum is not expensive and is abundant. Okay, my friend, now we are going to talk about the ferrous alloys. The ferrous alloys, they have a special consideration in our book of corrosion, because this is the ferrous alloys are based on iron, and if you remember, iron is the most corrosive metal in the periodic table. Iron is the element that is easily corroded when the metal is exposed to the environment, to the sun, to the rain. Okay, the ferrous alloys are divided in three main groups. One group is cast irons. The second group is plain carbon steels, and we have special alloys. Alloys steel specialized in each industry. Alright, now we are going to analyze each of those. And the price of those alloys increase. In other words, the special alloys are expensive. The plain carbon steels are medium in price, and the cheapest are the cast iron. Those prices, cast iron are the cheapest, regular steels medium, and specialized steel alloys are too expensive. And those alloys, the price of the alloys and the quality of the alloy depend on the concentration of carbon. In cast irons, the concentration of carbon is too high. In medium steels, and is too low in special steel alloys. This is the concentration of carbon. Yeah, in cast irons, the concentration is high, too high. This is the percentage. I want that you keep in mind that explanation. The cast iron, the concentration of carbon is in between 2 and 4% in the total weight. In between 2 and 4% of the total weight of the alloy is carbon. If the concentration is around 2 or 4%, we have a cast iron. The cast iron, the quality is not good, it's fragile, it's highly corrosive, the final texture is not good, it's not smooth. Cast iron is not fine. For that reason, it's used for non-expensive parts in the construction, in the automotive industry, in the marine. Right now we are going to analyze where you found cast iron. Don't forget, the concentration of carbon is in between 2 and 4% in the total weight. The steels are, the percentage is in hundreds of the percentage. It's like this. The low carbon steels, they have a maximum 0.3% of carbon. Yeah. We have after that the medium carbon steels. They have in between 0.3 and 0.5% of carbon. And the high carbon steels, high content of carbon, they have a concentration around in between 0.5 and 1% of carbon. Okay, don't forget, low carbon around 0.3% of carbon, medium carbon steels in between 0.3 and 0.5% of carbon, and high carbon steels in between 0.5 and 1.05% of carbon. Important, stainless steels, because the people always relate steels with stainless steel. Stainless steel is a special steel alloy. This is a carbon, this is a steel alloy with a concentration of 0.08% of carbon. 0.08% of carbon maximum. Yeah, 0.08% of carbon. This is considered a low carbon steel alloy because it's 0.08. It's less than 0.3%. It's considered a low carbon steel. For that reason, it's a special alloy with special properties, with special characteristics. It's low carbon content, 0.08%. In the total weight, 0.08% is carbon. This is for stainless steel. This is a special consideration. Okay, my friends, we are going to analyze the cast irons. The first group, the groups with a high content of carbon. Remember, is in between 2 and 4% of carbon. It's a cast iron. Cast iron have a high levels of carbon, For that reason, it's hard, it's brittle, and it's highly corrosive. Okay, it's used in the construction of short belts and in pans, in railroads. It's commonly used in the construction of the wheels, the construction of the brake pads of the railroads is in cast iron because it's cheap. Okay, the concentration is in between 3.5 and 4% of carbon. Okay, and 5% of manganese, 0.13% of phosphorus and sulfur and silica. Those are bad contaminants. You remember when we analyzed the diesel? You remember what is the enemy of the diesel? Yes, the concentration of sulfur and phosphorus and carbon. And you remember that we found that diesels of bad quality and diesels of medium quality and diesel of high quality and biodiesels. The biodiesel at the end, after the explosion, produced zero nitrous oxide, zero sulfur oxide, practically zero. It's a little, and the same with the sulfur oxide. Exactly the same with the cast iron. The cast iron have a high content of phosphorus, high content of sulfur, high content of silica. For that reason, the texture, the quality is not good because those impurities are no good and too much concentration of carbon. Let me explain what is the problem with carbon. Carbon is magic. You remember carbon located in the group number 4 of the periodic table? Carbon is in the group of the semiconductors material. You remember? Carbon, silica, and germanium. Those 3 elements are considered semiconductors. They work like metals or non-metals depending on the temperature. But carbon, the structure of carbon is a perfect structure because in the last orbit have 4 electrons. And remember this. If I have, for example, carbon fiber, let me check how is the structure of carbon fiber. I have pure carbons. With 4 electrons in the last orbits. Graphite is carbon. Pure carbons. This is the typical structure of a mat of carbon in order to create the pieces of carbon fiber. And those carbons produce a covalent bonding. You remember with the next carbon and other covalent with the other one and other covalent relation with the other one. In other words, all the carbons complete in the last orbit 8 electrons. They complete in the last orbit 8 electrons because they have 4 and 4 of the neighbor is 8. For that reason, those structures are perfect. It's practically impossible introduce an impurity because the structure is perfect. My neighbor, and my neighbor, we share electrons and we are perfect. For that reason, that structure, the mat of a carbon fiber, is perfect. It's rigid. For that reason, the structure of carbon fiber reach tensile strengths superior than steel alloys because this is a perfect structure. It's impossible to introduce impurities. The same situation occurs with silica. Silica is also in the group number 4 and produce exactly the same situation. For that reason, the mat of fiberglass, that one, is perfect, and the structure of the fiberglass is heavy. It's better in carbon, but the fiberglass is also heavy structures, and today the majority of the hulls are fabricated in in carbon fiber or in fiberglass, both of them, both structures, the structure of carbon and the structure of silica. Excellent structures. Okay, my friend, carbon is magic. You remember that depending how is configured the atoms of how are configured the atoms of carbon, you have a diamond. Yes, diamond is carbon. Is carbon with a special configuration of the atoms. Diamonds, the hard material in the world, diamonds is pure carbon. And it's transparent, it's clear. If you have a diamond, it's clear. It's incredible, no? How that microstructure is produced. This is produced on the ground under higher pressures and temperatures. For that reason, found that diamonds is not easy. There are special mines of diamonds, and find transparent, clear diamonds is practically impossible, but there are. And also in the laboratory there are scientific engineers dedicated to produce synthetic diamonds. Those synthetic diamonds, the color is a little blue in comparison with the natural diamonds. But those synthetic diamonds have similar structures. The diamonds are used in luxury for ladies loved diamonds, but diamonds are also used in cutting machines, in cutting tools. For that reason, you found that there are specialized tools covered the surface with diamond. Diamond drill bits, diamond saws, yeah, it's because they are covered in the surface with diamond. Diamond coated everything is the structure. Okay, those pieces of carbon inserted in the steel alloy are no good. Damage the properties of the original iron. Those impurities of carbon are the impurities that produce that the cast iron be cheaper. More carbon is more cheaper. Less carbon is better, because the iron, the pure iron, can be alloyed with other metals in order to produce excellent alloys. The enemy is the carbon, the concentration of carbon. For that reason, the cast irons with high concentration of carbons is cheap, but it's not good. If you have a cast iron alloy, it's difficult to weld those alloys, practically impossible. The welding area, in the boundary of the welding area, is produced a lot of stress, a lot of fatigue, and at the end of the day, those pieces are cracked in that area, around the welding area, because the carbon deposits. In other words, the carbon in some cases is magic, is wonderful, is diamond. In other cases, you remember in our course of hydraulic systems and auxiliary systems, the graphite is used like a lubricant. It's incredible, no? The graphite have a lot of properties. It's used like lubricant, and is perfect in the. You remember in the stuffing box, the PPS stuffing box, with the color of graphite in front of the color of stainless steel, produce a perfect seal and the water not penetrate. But in this particular case, those impurities of carbon are not good, because damage the structure and are excellent to start the propagation of cracks. Yeah, for that reason, the pure or the most expensive steel alloys, they have a low concentration of carbon. low, practically nothing. But it's difficult to remove those carbon deposits. And there are heat treatments specialized to concentrate those carbons, and in order to produce that the concentration of those carbon deposits be spherical. Because if the concentration of those carbon deposits is not circular, the cracks are propagated easily. And with the circular spheroidal concentration of carbon, the structure of the alloy is better. We are going to analyze right now those different type of structures. Okay, we are going to start with the cast iron with higher concentration of carbon. This is the typical cast iron with a concentration of carbon in between 2.5 and 4% of carbon. Yes, it's cheap. It's used to fabricate pans, utensils, and have carbon, a lot of carbon, and a lot of silica. No good. Silica is sand. Yeah. The name of this alloy is pig iron. Yeah. It's hard on the skin, but is easy to break. Yeah, and is corroded easily, and is in price the cheapest. The pig iron, the cast iron is the cheapest. There are other one in between. Is the gray iron, the gray cast iron. The block of the engines, not the liners, my friends. You remember the liners that we insert in the block? The block is gray iron. The liners is a special steel alloy. A special steel alloy with a chromium, molybdenum. You remember? Okay, it's not special. But the sleeves are separated. The block is in gray cast iron. For that reason, when the block is broken, garbage, replace the block. You need a new block and put new sleeves, new cylinders, new liners. Yes, the block, the housing of the transmission is in gray cast iron. Yeah, the housing of the differential in your car is in gray cast iron. And the structure, you see the concentration of the carbon deposit is not cylindrical, it's not spherical. It's a long, like this, you see? Long pieces of carbon. For that reason, that structure is not perfect. Because those black concentration is the concentration of carbon. If you cut it, the cast iron, you polish like a mirror, and you check with the microscope, you see those structures. Yes, my friend, if you study mechanical engineer, one area of the mechanical engineer is metallurgical process. And you can be a doctoral degree in metallurgical process. In NASA, there are a lot of doctors in metallurgical process, because you know, in NASA, in the construction of rockets, how important is the analysis of the materials? How critical is the selection of the materials, the classification of the materials, the production of special alloys? Yes, my friends, in NASA is where the majority of the new discovered in special alloys are, and also in the military, in the Navy. Those engineers are special metallurgical engineers dedicated to investigate about, to research about new alloys. Okay, this is the gray cast iron. It's used in the fabrication of blocks. Yes, they are used. They are excellent for vibration, high compression stress, good matchability, exceptional heat transfer, and the price is low cost. They are used in the fabrication of brake drums, engine blocks, pulleys, hydraulic valves. Yeah, a lot of fabrication in the industry. Gray cast iron, no black. Black is for home appliance. Okay, and yes, this is the difference between the gray cast iron and white cast iron. White cast iron have less concentration of carbon, and the carbon the carbon is aggruppated, is consolidated in spherical areas. Those spherical areas. Yes, this is white cast iron. This is superior. This is a spheroidal alloy. Can I convert gray cast iron into, yes, during the process of preparation of the alloy, they added special ingredients, zinc, and other ingredients that help that the carbon be aggruppated in circular areas, and also heat treatments. When the cast iron is finished with a heat treatment, they can improve the concentration of carbon in different ways, or the organization of the carbon deposit in different ways. Yeah, this is all of this is part of that big career, the metallurgical career. This is another wonderful career. Okay, my friends, and yes, the white cast iron. The white cast iron has superior tensile strength and malleability, is better, and is also known as the spheroidal iron or malleable iron, cast iron. Is used in the fabrication of rotors for brakes, in the fabrication of manifolds, because it have less contraction and torsional distortion. It is excellent. The white cast iron, because the concentration of carbon is less, right? Gray is better than plain cast iron, but the white cast iron is superior. Okay, this is the white cast iron. The white cast iron has carbide impurities, which allow that the cracks pass straight. Yeah, because the concentration of the impurities is cylindrical. Since carbide makes up a larger fraction of the material, white cast iron could reasonable classification as a cement. Yeah, this is the other name for the was iron, cermet. Yep, the white iron is brittle and is used in many structural components, especially in the automotive, in the aviation, in the fabrication basically of engines and propulsion systems. Is commonly used. White cast iron. Yeah, this is another great example. Is in the housing of the turbos. The housing of the turbos is in white cast iron.